Well, I'm back again, and I'm trying to jazz up this video a little bit. I'm looking at some of my old ones, and most recent ones I'm looking very old and tired and sad. So I'm going to try to make this one a little bit peppier. I can't do anything about my age, I guess, but maybe I can smile and try to make things look a little bit nicer. I'm wearing my hat today, a Nike hat, not because I advertise for Nike, but because I like that Nike swoosh is a sign of victory. And this is a Holy Week, which ends with us celebrating the ultimate victory of Jesus Christ over death. So that's going to remind me of what we're getting into here with Holy Week. But we also have to do chemistry, so let's get going. Today we're going to do a decomposition reaction involving hydrogen peroxide. There it is. This hydrogen peroxide is actually, I think it says a solution of hydrogen peroxide. Solution. That means it's mixed with water, and if you read the fine print, you'll see it's 3%, which means 3% hydrogen peroxide, 97% water. That means the hydrogen peroxide is a solute, water solvent. And the formula for hydrogen peroxide is also written on here. It's H2O2. I'm going to put a little bit of that in my test tube here. And then to this hydrogen peroxide, okay, probably about half a test tube or so. To this hydrogen peroxide, I'm going to add a little bit of yeast. And you might think, what are you doing here? You're going to make some hydrogen peroxide bread? No, I'm not making hydrogen peroxide bread. I'm going to use the enzymes in the hydrogen peroxide to act as a catalyst to decompose the hydrogen peroxide, because the hydrogen peroxide is kind of unstable to begin with. It would like to be H2O, but it's not. It's H2O2. And so it's wanting to break down into a simpler compound, a simpler compound and element. And I'm going to hasten that process by adding the catalyst that's in this yeast. So I'm going to put some in there. There it goes. Boom, right in there. And I think what I'll do is shake this up. Shaking it now. Now, there she goes. And it's reacting. You could probably see the bubbles. It's going to make a nice little mess here. But I'm getting a lot of bubbles. That means a gas is being generated. And we're going to try to figure out what that gas is. Here we go. Let's put that back in there by doing a flame test. So I'm going to need a source of flame. I'm going to get that by turning on the gas here and using my activation energy to make another reaction here. This is a reaction involving methane and oxygen. I had to add activation energy, and sooner or later I'll have to write an equation for that too. But here we go. This is really going to town here, this little reaction. So I'm going to add a little bit of, I'm going to do the oxygen test first. The oxygen test is take a glowing splint. There it is. It's glowing. Can you see it? And put it in the gas. If it reignites, which it did, that's a symbol of oxygen present. I've got positive tests for oxygen. Let me double check that. By golly, that is oxygen. Now I'm going to do the hydrogen test. See if we have hydrogen. Hydrogen is a flaming splint. Gives a barking pop. So here goes my flaming splint. And I didn't get a barking pop. It just kind of burnt more vigorously, which is a negative sign for hydrogen. Hydrogen not present. But that burning more vigorously, that reignition of that indicates the presence of oxygen. So now that we've done that, we could just kind of examine the test tube. The test tube is feeling a little bit warm, and that indicates that this type of chemical reaction is giving off energy, which means it's exothermic. Just like this one's exothermic, because if I went over here and grabbed this fire, it would feel warm. So I got two exothermic reactions going on here. This one, oddly enough, is called a combustion reaction. This one is a decomposition reaction because I'm decomposing the hydrogen peroxide in the presence of a catalyst. The catalyst goes above the arrow. So there's really only one reactant here, the hydrogen peroxide. And it's producing oxygen gas. And is there another product? What do you think? Can matter be destroyed? And the answer to that, of course, is no, it can't be destroyed. So there has to be another product. You'd probably like it to be hydrogen, wouldn't you? Because that would be simple. But is hydrogen one of the products? No. We tested and we found it wasn't one of the products. What could it be? Well, since we can't create or destroy any atoms, we only had hydrogen and oxygen reactants, then a logical guess for the other product would be a compound containing hydrogen and oxygen. And there is a very stable compound that contains hydrogen and oxygen, and that is water. So there you have all the products and reactants. You could write the equation and balance it now.